Hello everyone, today we are going to talk about end-to-end multimodal emotion recognition. So firstly, what is end-to-end? That means you train the raw data directly instead of feature extracted from the raw data as input. And what is multimodal means? Multimodal means you train both audio and video data. In our project, we not only train our own multimodal model, but also compare with video-only and audio-only input model to get a conclusion. The second part is pre-processing part. The dataset we use is Rapidus. It is generated by SmartLab, and we have both audio and video data for 24 actors. We will use 20 for the training process and the rest 4 for testing. It includes 8 different emotions. Here is an example of 8 different emotions in this dataset. And for the pre-processing part, it is divided into 2 parts. For the audio part, we will use 2 different methods to process audio data. The first one, we will use the browser package to extract MFCC features of audio data. And the second one, we will use our own autoencoder structure to get the features we want. For video part, we will take several steps to reduce the size of the image in order to reduce the training time, and only keep the important information of the human face.
Now I will introduce the model architecture. Our model can be separated into 3 subsystems: the audio, video, and audio-visual subsystems. You may ask why we design such architecture. The reason is that this architecture can model the temporal information within and across modalities. For audio subsystems, 2 architectures are constructed. On the left side is a normal one. We use the MFCC features as the input and use 2 dense layers, 2 GRU layers, for feature extraction. On the right side, we use an autoencoder to extract the features. So, what is autoencoder? Autoencoder has 3 parts: encoder, bottleneck, and decoder. The encoder network can be seen as a dimension reduction part, and the role is to translate the original high-dimensional input into the low-dimensional code. The bottleneck is just those low-dimensional code, and the decoder can recover the data from the code. In practice, we pre-train the autoencoder network and use the encoder part to extract features. Now, let's have a look at the video subsystem. 70 images from one video are fed to the 3 convolutional neural networks for feature extraction. After a global average pooling layer, we integrate these 70 results and feed to 2 GRU layers to capturing the temporal dependencies. After that, the outputs from these 2 subsystems are concatenated and fed into the audio-visual subsystem. They first come to 2 GRU layers and then to 2 dense layers to predict which of the 8 emotions the actor is. The above is all our models.
Let's look at the training performance together. From the figure, we can find the performance look good, but there exists overfitting problem for both models. Then let's move on to have some analysis on our model's architecture and the performance of the training model. Beside of the proposed frameworks, we also tried audio-only recognition systems as a baseline systems for performance comparison. Firstly, we could note that in multimodal recognition system, the number of parameters and the running time increase a lot because a video subsystem is added. Then we can find that the performance of multimodal systems are better than the performance of audio-only systems, regardless of how we extract audio features. Hence, we may have the conclusion that multimodal emotion recognition system could improve classification performance. Beside of multimodal, end-to-end is another big characteristic of our work, and is an improvement compared with traditional emotion recognition system. We can find that even though the performance of the model trained with raw audio data is not that better than the model trained with handcrafted features in validation set and test set, the difference is acceptable. It means our idea of using autoencoder as feature extraction to train the emotion recognition system is plausible. There are some directions lead to our future research. Firstly, we plan to use GAN to generate synthetic data to expand the dataset. Besides, it's better for us to include more database for training and evaluation. As for the model, we intend to improve the architecture of autoencoder to extract more flexible and reasonable features. Moreover, because currently our trained models have the overfitting problem, we still need to adapt hyperparameters to overcome this issue. We are sure, after further investigations, our end-to-end multimodal emotion recognition system will perform outstanding compared with previous work. That's all of our introduction. Thank you for watching.